All right. Well, good afternoon, everyone. Let's get started. Well, first off, thank you for attending the first in a series of MECCO webinars designed to share information with our existing customers and potentially our future customers. My name is Scott Cunningham, and I'm the sales manager at MECCO. I've been heavily involved in direct part marketing for close to 20 years now, and I'm excited to share some of my experience with you and your colleagues in this webinar. Everyone is, at this point, is muted, but if you have any questions or feel free to write into the chat, and then as we get to the end of the webinar, I'll open it up for questions that you guys are asking. So just advance the slide. So to start things off, we create a poll wanting to find out which of the following were the most pressing for you considering the times that we're in right now. I'm going to launch this poll to you guys, and if you can just respond back with your answer, we'll share the results at the end of the webinar. Okay. Okay, so it looks like we're collecting the responses now. And like I said, we'll share the responses as we go. So the primary objective of this webinar is really going to be to share with you a wide variety of solutions that you may not already be aware of, and to show these solutions so that it can be used to optimize your processes, lead to controlling costs, lowering supply chain risk, and increasing efficiency and boosting overall competitiveness. I'm getting an error on my side. Let me just pause something real quick and I'll be right back on the line. Okay. All right. Sorry, I was having some connection issues there. I'm not sure. So anyway, regardless of what you answered, you're not alone. So we pulled this information from the National Association of Manufacturers about 2 months ago, and essentially more than 3/4 of manufacturers anticipate a financial impact from the COVID crisis. More than half at that point in time foresaw operational changes, and then 1/3 expected supply chain disruptions. So as we navigate the new normal, we at MECCO are looking to leverage technology to better support our customers in the future. So we've already been remoting into systems from the service side, hosting web meetings and virtual demonstrations, and even conducting some system runoffs over online platforms. So while it's challenging, there's some significant benefits that we've actually been able to see, such as being able to quickly be in front of customers without all the logistics of traveling. We're also able to pull in more of our team members and our resident experts, and we've seen the collaboration and the frequency and participation increase from our customers as well. So across different business units, different groups that have been geographically isolated, getting together and getting on joint calls with us as well. So, all right. So, it is my goal that over the next 30 minutes, that you walk away with some ideas on how you're able to lower your operational costs by implementing direct part marking solutions. I'll provide you with some rules for how to choose the best system for your needs. We've got some tips to help boost efficiency and process accuracy. And I'll share some benefits that companies already using track and trace solutions have shared with me. So lastly, we'll discuss some best practices that companies are using to enable traceability through their supply chains. And again, this is being the first one, this is going to be very high level, but we will have future webinars to get more down the weeds on the specifics. All right, so why choose direct part marking? So in this webinar, we're only going to be discussing variable direct part marking technologies and the benefits associated with permanently marking parts. A lot of customers over the years have told us about challenges they face with adhesive labels, inkjets, paint marks, pad prints, and then static marking such as stamping and die inserts are really not talking about with part-to-part differentiation. So the two technologies we're going to focus on in this webinar are the laser technology and pin marking technology. So laser technology really provides the greatest amount of versatility. Depending on the type of laser, you can make marks on metals, polymers, coatings, packaging, really all sorts of substrates. And as the price of lasers has come down over time and the power levels have increased, we're seeing more and more justification to go with laser for applications, from surface etching to deep engraving applications that will survive postmark processes like shot blast or paint. With laser marking, there are special considerations like laser safety, environmental requirements. It has to, needs to be a fairly clean environment for the laser to work. Hold on 1 second. Okay, I see a hand raised here. I'll try to answer that in a second here. Sorry about that. So, sorry, I had another connection issue. I'm not sure if the audio is coming through or breaking up for you guys, but I'll do what I can to try to stay on track. So, on the we talked about with laser marking, there are some special considerations, laser safety, different environmental requirements, and then the design of the load-unload process. So lasers are used for a lot of marks where the aesthetics of the mark are important. So marks that are going to go to customers and be used for branding or where the quality of the mark is critical. On the pin marking side, pin marking technology is great for marks that are more utilitarian in nature. So, you know, marks that, for example, date codes or part numbers or things that are used more for internal tracking. So we have some customers that actually will use both technologies on the same product. They'll actually apply a pin mark on their product very early in the process. That mark will be used to go through different machining operations and different processes. And then after all the machining is complete, they'll actually apply a laser mark on the product with a high resolution, high quality mark for their customer. And another area where dot peen is really valued is in the aerospace industry. So there's still some legacy concerns related to potential stress fractures that could be caused by thermal processes like laser. So in those environments, they often require that a dot peen mark be put on this critical component. Also, when there's a need to mark very large parts, maybe in a storage yard, or where the portability of pin marking can be a big benefit to customers, those are other good areas where pin marking wins out in terms of technology. Really are two different types of marking. There's the simple, basic part identification. This could be anything from part numbers, date codes, serial numbers, logos, customer instructions, and more. Then there are more complex marks where a unique identification is provided to the product, and a manufacturing MES system or an operations database is used to actually track that product through the different processes. So I'll give you an example here in a second. So in the case of a track and trace, that can greatly reduce the number of times that you may need to mark a product. So for example, I've seen some customers, some companies applying special markings after testing to show the product passed a certain test or operation. And if a product maybe goes through 2 or 3 different tests or operations and gets multiple marks, if that information can be recorded instead in a relational database, then there's a lot more error proofing that can be done. So for example, if you can put a 2D code on a product, track it into an operation, test it, pass the test or fail the test regardless, append that information of what its test results were to the MES system, and then you can really look to eliminate any potential errors, skip operations, skip tests, things that could escape out to the customer. So there's a lot more to traceability solutions and what goes into those solutions, and we're planning on covering that in a separate webinar. But just high level, when you're thinking about marking, think about what the end goal of the mark is and what you need to do. So once you determine what type of marking you're trying to achieve, then it's time to consider, what the right marking technology is going to be. So materials that are being marked, the current manufacturing process, enterprise level requirements, all will play into that decision on, which type of equipment is right to use. So we like to ask a lot of questions of the companies we work with in this stage of, how is the part presented for marking? Is this a batch process where lots of different parts are made in lines and they're all coming to like a central marking station? Or is it an inline marking station where it's another operation of sort of inline or more in a lean mode? there's pros and cons to both. Batch marking centers have certainly better utilization. A lot of times you're above 95% utilization by having a single station do all the marking. But they require a lot more in the way of versatility. And a lot of companies have experienced bottlenecks in throughput. So when their production demand is high, they don't. When the production demand is really high, they can't keep up, and so the marking system becomes a point in the process that causes delays. So on the other hand, inline solutions are used when products being run through the line, and we tend to see this more in high volume, low mixed applications. So the other thing that we always want to ask is, how is the machine being tended? Is it going to be loaded with a robot handling system, robot presenting it to the marker, or is it going to have a human interface? We've designed many standard systems that will have operators interfacing with the systems, as well as systems that do handoffs to robots as well. When the operators are involved, there are a lot of cases where, if you look in the middle of the screen, where we actually work to develop specific graphical user interfaces that will simplify all the capabilities of the marking system to really just what is specific to that operation and what that operator needs to worry about in that moment. We combine the manufacturing process with our software, and we've done a lot of GUIs that will do things such as show the operator where that mark will overlay on their parts before they actually start the marking process. Show them that the right information is being pulled in, show them what information is being pulled in, and maybe even do a confirmation step to make sure that is the right part in their process. In more automated cells, we've even tied in with our customers' ERP systems and been able to pull the data for marking. So in short, the best option for you and for your project is really going to be based on high level, your materials being marked, your current manufacturing process, and ultimately your vision for how it all comes together, your vision for integrating that all together. So before we jump right into all the different technologies, I want to preface this by saying you don't need to remember all of the stuff I'm going to tell you. Our application engineers are experts in determining what best meets the application requirements. We have all the different technologies available for empirical testing in our labs, but at the same time, I'm not planning to go very in-depth into all the different types of lasers and pin marking technologies we offer in this webinar either. So really, I'm looking to stay somewhat high level and give you some high level rules of thumbs for what we would use for picking the right technology, and why we might choose one technology over another in certain examples. So the first laser technology that we'll discuss is the fiber laser. The fiber laser comes in a wide range of power levels from 20 watts up to 200 watts, and those are the pulse lasers. And we even offer 300 watts for a continuous wave. Applications like that might be like polymer welding. So the fibers are extremely versatile, and they can be used to mark a wide variety of materials. The standard fiber can etch into metals, anneal into metals, and as well can be used on a lot of different plastics and other substrates. We will use oftentimes the higher powered fiber lasers for applications where we need to engrave to some depth. So one good example of that is deep engraving serial numbers on firearms. You know, according to the ATF, you have to be 6 thousandths deep into those firearm, and so when we're doing, you know, deep engraving applications, it's one where we'll use a higher wattage fiber laser. Another application might be where we're trying to survive a post process, such as a shot blast or some type of coating that's going to be applied. So anytime we're trying to, you know, bite in the material quickly, the fiber is a good sort of go-to solution. It's notable too that we have shorter wavelength lasers with the fiber technology as well. So some polymers seem to react better with shorter wavelengths. You get more of a photochemical reaction versus a photophysical or more of a thermal interaction. And so in those cases, you know, again, the fiber might be the right choice. So key takeaway here, when versatility and flexibility are important, you're doing different parts, different materials, the fiber tends to be the choice that we go with. The next technology I'm going to talk about is diode pump technology. So diode pump technology has some advantages over fiber. Typically, we see it on some types of plastics. So it really comes down to the shorter pulse width. That's the duration of time that the laser is on per pulse. That shorter pulse width means that, you know, you're putting same amount of energy in a shorter width, and so you're getting higher peak energy. You're kind of doing the work without the negative effect of burning it. So if you look at some of the examples that I'm sharing here with you, on the left-hand side, you see the diode pump laser, and on the right-hand side, you see a 10-watt fiber laser. And so for some materials, you're able to get a little bit more contrast, you know, or a little bit better quality of mark with the diode laser. On the other hand, the trade-off is that sometimes the mark time is longer than it is with the fiber. So, you know, we work quite a bit to try to balance, you know, the mark quality, overall cycle time requirements, and, you know, any other variables that we need to consider. So, again, we empirically test everything in our lab. So, if one technology is a better fit than the other, we're certainly going to recommend it, but also, you know, kind of prove the differences. And then the last laser technology to talk about really is a CO2 laser. The CO2 laser is a technology we offer primarily for organic materials. So on plastics and on rubbers, you know, you can typically achieve a non-contrast engraved mark. On other substrates like paper, wood, e-coatings, you can typically achieve some level of contrast. Due to the longer wavelength of the CO2 laser, the laser tends to have more of a photophysical effect on the material. So, you know, in other words, you're burning or melting the material away. Laser safety for the CO2 is a little bit different as well, because of the longer wavelength. Things like safety glasses will essentially block the beam. One interesting area where, you know, CO2 laser comes into play is, you know, face shields and polymers like that, where, you know, maybe you don't want a real visible distracting mark, but you need something that's almost like a molded in look. And so if you need variable information, but you don't want to have contrast, it's a great alternative to some of the other lasers. All right. So like I said, that was the last of it on the laser technologies, and we will do a much deeper dive into laser technologies and other future webinars. So on the pin marking side of things, we generally start with determining what the overall mark size needs to be on the product. Now, this is a little bit different than with laser. With lasers, we can apply different lens sizes and get different mark fields, but with the pin marking, we need to know that up front, because being a mechanical process, the mark window is really a function of the system. So we also need to determine things like, is it a stationary system? Are parts going to come to the marking head, or is it a portable system where an operator is going to go out and take the product, the marking system to the parts? Or is it some combination of the two, or is it an automated cell where parts are being presented to an inline integrated marking head? We also need to determine, is it a dot peen application, vibra peen, or a scribe mark? And there's different reasons for going with different technologies. The vibra peen offers a real great quality mark in the fastest time, but some applications require lower noise. So in situations like that, a scriber may be the right technology, because it doesn't have the same amount of noise. Instead of repeatedly hitting the part, it comes down and sort of drags through the part. Now, the trade-off there, and the thing to consider, is that now you have to fixture with more say lateral loads. So because the pin is sort of dragging through the material, it's pulling the part in different directions. So you have to be more firmly fixtured than if you're just coming down from a single point from above. Another thing to discuss is post, just like with laser and deep engraving, we have deep pin marking. So deep marking systems are ideal for applications where maybe the material is being subjected to extreme wear, or when a coating is being applied. So some examples of when we would need to go to a deep marking solution would be downhole drilling in the oil and gas industry. So things that are going to go into the ground, and the mark is potentially going to wear off because the material itself is wearing off. Another example is structural steel that gets painted or gets galvanized. So in those cases, we need to go really deep into the material, and we have that type of solution as well. And then lastly, on the pin marking side, if cycle time is a concern, our fast pin marking solutions come into play for high volume automated environments. These solutions have limited window sizes due to the pivot design, but if speed's important, we would lean toward recommending this type of solution. So, all right, so that kind of covers how we would pick different marking technologies. Now, we're going to talk a little bit about airproofing and how vision systems can help. When we integrate vision systems, can help with our airproofing. So at MECCO, we've integrated vision solutions, and in the majority of cases, they're used to check the quality of the mark after the mark is made. So in those cases, as you can see on the left-hand side, we'll verify that the information in the 1D or 2D code itself is the right information. We will actually grade the quality of the 2D code based on industry-defined metrics for assessing the mark quality. And then that information is typically recorded and sent to an external database. There are other things we can do with vision as well. On the pre-mark side, things like part confirmation, part recognition, and even part alignment. So if the part is positioned under the marking system at an angle, we can offset the marking system to make as I described it, a crooked mark on a crooked part. So we'll actually have another webinar on integrating vision with marking, and we'll drill further into this topic, but just something to keep. Vision applications can be a good way to error-proof. And then lastly, my final optimization tip for today is connecting with the data. So like I said before, with reducing costs, going into high-tech automation is really important. This is where we get into true traceability and taking that information and connecting to your database. So data really gives you a competitive advantage. It's tough to determine the value of data until you're collecting it, but in 2017, The Economist declared that data was the world's most valuable resource. So in addition to the data that you can pull from products in your manufacturing process, you can also get greater visibility and coordination across the supply chain. So a lot of companies require traceability not just within their walls, but from their suppliers. And so having that supply chain continuity enabled is a great way to be able to track all the way through from cradle to grave. So one way that MECCO helps to enable connecting with data is through the use of graphical user interfaces or GUIs. So if you have a PC-based application, I talked about GUIs for the benefit of simplifying the operation for the operators, but they also in the background can do a lot of data manipulation, either pulling from and or sending data out to an external system. And if a PC is not required, another way to get that type of connectivity is through MECCO's EtherMark software. This would allow you to basically network the marking systems without PCs and send information from PLCs. And again, back to some of the other things we talked about, not just sending the information itself, but sending information about, for different materials so that the settings for the marking can change, or offset information. So if you need to make a crooked mark on a crooked part, that information can all be sent through PLCs. So just a different way of thinking of how to integrate everything together. So in closing, I hope that you have a better idea of really what goes into choosing the right laser or pin marking system for your operation, and that how to think about adding automated reading and verification, and really lastly that you leave kind of with some thoughts on how you may be able to use direct part marking to enable a better, smarter manufacturing system in your plant. Industry 4.0, all of that sort of being enabled with starting with the unique ID on the product itself. So, at MECCO, we have developed a systematic process to help companies navigate through those stages of a project. We start with requirements defining, move to technical feasibility, and then carrying that through with the solution development. We have a full team of sales engineers, integration engineers, application engineers, and service engineers that get involved throughout the different stages of a project, and we're here ready to help. So if you have a project or you want to consider something, please reach out to us and see if we can help with your needs. So lastly, I'll take any questions that you guys have in the question box. Just feel free to ask away. If you enjoyed this webinar and found it useful, just be sure to sign up for the next one, and we'll be sending out an email with our next upcoming webinar. Appreciate your time and attention. Okay, just have one question and ask if we can send this stuff out afterward. The webinar was recorded, so yeah, we'll get a recording of this out immediately following. Oh, and I did promise you guys the results of the polls. So, of everyone that voted, what are your most urgent challenges? The highest one, 42% of you said that efficiency needs, doing more with less. 32% said lowering your production costs. 18% said readiness planning for the new normal, and 8% said supply chain volatility. So hopefully you guys found this useful, and thanks for attending.